Just like a smoke detector in our home, our body has a built-in alarm system. Alarmins are molecules that alert the immune system of any potential threat. For example, when our lungs are exposed to viruses or bacteria, these alarmins get activated and start a cascade of events leading to inflammation, like an alarm that alerts and brings the fire brigade. Now imagine if the smoke detector also goes off when there is just a bit of steam from cooking. Similarly, our body's alarmins can also get activated by harmless things like dust or pollen sometimes. This is a false alarm that leads to inflammation. One important alarmin is TSLP or thymic stromal lymphopoietin, which is implicated in asthma. In asthma, while all patients have poor lung function, they exhibit diverse features in the clinic. Thus, it is important to find the right treatment for the right patient. Recently, a new therapy that targets TSLP has been developed. However, we are not sure of the ideal asthma patients for this. In my project, I am asking 3 key questions about this alarmin and letting patients help me answer those. First is that which of these patients have that oversensitive detector, and is there a way to identify them easily? For this, I have measured TSLP in the airway fluid of asthma patients and found that about 1/3 of them have high TSLP levels, and these levels are strongly associated with a type of inflammation called type 2 inflammation, where patients have high numbers of white blood cells called eosinophils. Thus, we have identified a subset of patients where TSLP is high, and we know of the markers to identify them easily in the clinic for this therapy. Next, we want to know more about this detector. What are its sources in the lungs? For this, we are carrying out imaging technologies on the lung sections of asthma patients to find the part of the building where the detector is located. And we have narrowed it down to basal cells, which are special lung cells. Finally, we want to look closely at the detector itself. Using RNA sequencing technology, we are trying to, understand the wiring of the detector to see if we can repair it. Overall, in my project, we have identified the ideal asthma patients for this TSLP blocking therapy, and we are exploring the biology of this alarmin to help patients breathe easier and live better. Thank you.